This lesson is going to examine the idea of a tangent equation. So we know the idea that when we're finding an IROC, an instantaneous rate of change, we have a graph, and I want to find the IROC at that point, we actually form a tangent. So in this lesson, we're going to look at the equation of those tangents. These lines all take the form y equals mx plus b. Okay? To find that equation, we need two things. We need to know a point, where do I hit the curve, and we need to know the slope. Well, those two things can be found by the function itself. That will help you find a point. Okay, so that's this first idea here. And the slope, well, we can use our derivative to find that. So you have to be a little bit careful about what am I finding, what's it going to be used for when you want to find these tangents. So let's start with an example here. For each of the following, explain what you're being asked to find, then calculate the value. So I'm looking at f at -1. What does that mean? I want to find the point. It's a point because I'm using the original function. The point where x equals -1. That's what I'm being asked to find in this first thing. I can do that by plugging in -1 into my function. So -1 to the 4. Well, that comes out to 1. So in other words, I have a point, -1 and 1 on this function somewhere. If you look at the second example, f prime at 2. What's that asking me to find? This is finding the slope, the slope because I'm using a prime, the slope of the tangent, in other words, the IROC, at the point where x equals 2. So I'm finding derivatives, I'm finding slopes. When I'm using functions, I'm finding points. Two different kind of things here. Okay, so I need to find this. But I got a messy equation. I get to change my equation. I don't like having x's on the bottom. So I'm going to rewrite this as x to the -1. Then I can find my derivative. 9x squared, remember, multiply our exponent times our base. And same thing with the next part, so plus 2x to the -2. And then I want to find f prime at 2. So if I'm working with equations, it's often easier to rewrite this exponent back to the bottom. So then when I find f prime at 2, I can sort of see a little bit better what's going on here. And you can put that into your calculator if you want to, or calculate each part separately. We should get 36.5. And this part's 36, and this part's a half, right? 2/4. And there's our equation. Or sorry, there's our slope at that point. Okay, so let's look at an application here, if you will. So we got sand being poured into a bucket for 30 seconds. After t seconds, the weight of the sand is given by this equation. Determine the weight of the sand after 10 seconds. So what's that asking for? It's asking for a certain point in time. How much does the sand weigh? Specifically at 10 seconds. So I'm going to use my function equation, putting 10 in for all the t's, because that's how much time has gone by. And I want to calculate what that comes out to. Well, if I try that, I end up with 4,000. This is in grams after 10 seconds. That's how much the bucket weighs. In part B, determine ds dt. ds dt is another way of saying find my derivative. I can do that using my derivative ideas. So 0.9 times t squared minus 36t plus 550. And this will give me the rate at which the sand is changing at any point. Part C, find and interpret the meaning of s prime at 10. Well, I can do that. It's another way of using my derivative, 0.9 times 10 squared. We're using this equation right here, right? 36 times 10 plus 550. And put it all into our calculators, and we should get 280. What does that mean? Well, it means at 10 seconds, the weight of the sand is increasing, and I know that because it's positive, at a rate, that's what we're finding a rate, IROC, of 280 grams per second. So the weight of the bucket went up 280 at that 10th second. That's how fast it went. Okay. So again, we're using the difference between points. This is how much the total weight of the bucket is at that point. And this is how fast the rate is changing at that point. Okay. Two different kinds of things. Okay. Let's do a little more theoretical thing for a second here. So to find a particular tangent and a normal, we'll talk about normals in a second. Okay. To find a particular tangent, that's a straight line. That's an mx plus b. Okay. A normal is related to that. It's the perpendicular to a tangent. So look at this diagram right here. You see your tangent at a certain point, point A. It's going this direction. Well, the normal will go the exact opposite direction. It's perpendicular. They go through the same point. And we can find that point using our function notation, our original equation. And they're perpendicular to each other. In other words, they have negative reciprocal slopes. So I can find the slope of my tangent using my derivative. And once I know that, I can find the slope of the normal by taking its perpendicular. Okay, that's really what we're going to do next. We're going to try one here. So find the equations of the tangent and the normal using the given information. So I've got a nice parabola. The parabola x squared. I want to find the tangent at -1. That's over here. Right. Well, to do that, I need to know what this point is. I know part of the point is -1 and something. So to figure out the rest of it, I've got to figure out what's happening at -1. Well, -1 squared is 1. So I've got myself a point. I also need a slope. Okay, my slope is coming from my derivative, but I don't have a derivative yet, so I need to find that. So my derivative is 2x. What derivative do I want? I want the one at -1. So f prime at -1 is 2 times -1, or in other words, -2. Using these two pieces of information, I can find my tangent. Right. How we're going to do that is I equals mx plus b. Our slope is -2. So I can fill that in right off the bat. To find b, I need a point, an x and a y. So I can put the 1 in for y, the -1 in for x, and solve for b. Let's give it a try. 1 equals 2 plus b, 1 minus 2 is b is -1. Therefore, my tangent is -2x minus 1, which looks kind of appropriate. It's going down to the right, and it's got a y-intercept that's in the negatives. To do the normal is the perpendicular lines to that point. So it's going to look like this. It's perpendicular. It's still a line, so it still follows mx plus b, but the slope is the negative reciprocal, the perpendicular slope. So reminders, I got to flip this over, so 2 over 1 becomes 1 over 2. It was a negative, so this becomes a positive. And then I do the exact same thing I did before. I fill in my slope. I'm using the same point because it goes through the same point. So 1 for y, -1 for x. So I get 1 equals -1/2 plus b, or in other words, 1 plus 1/2 is b. If you want to use decimals, that's fine. 0.5, there's nothing wrong with that. This will give you 1.5 for b. Therefore, my normal equation is 1/2 x plus 1.5. And I found the two lines that are kind of useful for us for finding things out. One's for IROC, and the normal is it's perpendicular. Okay, I'm going to give you guys to try this last one, okay? So same idea. It's different function. We don't need to draw it out. It's a cubic function. You don't need to worry about that. But I want you to find the tangent and the normal. So same kind of procedures. We need ourselves a point. I would pause this. Try yourself. See if you can do it. So our point. So I need to figure out y at 2. So 2 cubed plus 2 times 2 is 12. So there's my point. I need a slope. To find a slope, I need a derivative. So 3x squared plus 2. I want to find the slope at 2. So I need to put a 2 in for my x's, which gives us 14. Okay, so I've got 2 things I need to find. We'll do our tangent first. It's the easier of the 2. So my tangent, I'm going to fill in my slope that I know. I know right off the bat my slope is 14. I need to solve for b using a point. There's my point. So I'm going to fill it in for x and y and then solve for b. So 12 minus 28 is b, or negative 16 is b. Therefore, my tangent is 14x minus 16. And we're going to do the exact same thing for the normal, except for I need the perpendicular slope this time. So if my slope was 14, its perpendicular would be negative. That's the opposite sign. And I flip it over. This one's a little bit messy because we've got fractions in here, but that's okay. We can use the fraction button on our calculator. And x is 2. We do the exact same procedure. Negative 2 over 14 plus b. 12 plus 2 over 14 is b. And I use the fraction button on my calculator. It's going to reduce it. It's going to make it a 7th. Okay, but I get 85 over 7 is b. Therefore, my tangent, or sorry, my normal is negative 1/14 x plus 85 over 7. Right? And we found ourselves some normals and some tangents. So today's lesson, the big ideas are, what does fx give you? What does f prime x give you? And how can we use those sort of together to find normals and tangents? The homework for this lesson is a handout. Okay, so it's in your books already. And you can check the answers on the website. If you're stuck, come see me.